Paul, I've been told on many occasions by the Engineering Technology Group about how good these Nakamura NTRX 300 machines are. This is the first time I've seen one on site, first time we've been out onto a site to see one here at Rotec Engineering. Would you agree with them? Is it a great machine?
Yeah, it is a great machine. We've been involved with Nakamura now for about 12 years. Our experience with them has been fantastic machines, extremely reliable, very fast and very accurate. So in our endeavour to move forward in our technological growth programme, as we call it internally, we wanted to buy a machine that was going to be accurate, reliable, that we could program directly from the CAM system, which is full 5-axis turning. This is the reason we chose this particular machine.
You do have other mill turn machines in the company. You've got a lot of machine tools here, a lot of technology here. Firstly, congratulate you on that. It's great to come here to a machine shop like this. But this machine here just has a milling head and 2 spindles, doesn't it? Some of the other technology you've got has incorporated a bottom turret. Would you say you've kind of gone backwards with this, or is there a different idea behind the purchase?
Some people may regard that as a step backwards. We regard it as a step forwards, because what we're trying to do is change our philosophy through our continual measurement of what we do and our efficiencies on the shop floor. What we found is that actually by focusing on cycle times is not the right way forward. We found we get a lot of downtime between jobs. So the whole idea of this is to, by using our CAM system, reduce our setup times, create a tooling bank in the machine so we can set up jobs, complex parts very quickly, and not really focus on the cycle time too much. Focus on high quality finished parts that we can then run automatically by using the bar feed and the auxiliary loader on the machine to get the yield out of the machine over a given period of time.
It's quite interesting because it's quite uncommon for me to hear that come out of a managing director's mouth, the fact that you're not that worried about the cycle. I mean, you're worried about the cycle time, but you're not chasing seconds. You're after reliability, making the whole process less complicated in a sense, aren't you?
Absolutely. I mean, it is a very complicated process. There's lots of parts of the machines and bar feeds have to work together reliably, and that's been the challenge, is to make all that technology work seamlessly for us, and to a point where we can reliably trust the machines to run when people aren't here. We regularly run weekend shifts and nighttime shifts of machines running completely unmanned. And we believe that's the future of manufacturing in the UK. We want to be on the forefront of that.
Would you be running this machine day and night then?
That's the plan. At the moment, we're still getting to. Obviously, it's a relatively new machine, and getting the guys trained, etc. Takes time. And also, we're getting to grips with our new CAM system. The idea is we use the machinery in the man shifts for doing high-end automotive Formula One work or aerospace work, and then at night time we switch to existing programs, running off bar feeds, basically producing parts that you would look at and think actually they would be milled parts.
And you've got a halter robot on your other Nakamura machine that you've got here. Yeah. Is there ever any plans to do that with this machine as well, so you can not only do those complicated jobs reliably, but almost take the man away from the operation as well?
When we purchased this machine, the consensus will be put the halter on this, we interface the halter of this machine also. But actually, because of the way that the machine is actually, we filled it with existing work we already had, and it's got a bar feed unit on it already. And also it's got this auxiliary loader on the back where you can load billets into the machine. We don't really think that's necessary. Maybe if it's on the second machine, maybe we might configure it slightly different with a halter robot as opposed to a bar feed. Because of where we're at with absorbing the existing work within the company already, we probably won't do that in this particular case.
I mean, this is the big investment for your company. I know you've moved recently as well into this fabulous facility here. With some of the software you use as well, you can look at your overall equipment efficiency on this machine as well, can't you? So you can measure things like how much downtime you have. Is that right?
Absolutely. Yeah, we've invested quite heavily in a system called Simco, which is all the systems are networked together. It's quite a clever system because it's not biased between one manufacturer or another manufacturer. So we've got Chirons, Stars, Citizens, Nakamuras, DMG machines, all linked up to the system, and basically it gives us a really good view of our efficiency. And we can have that in a pictorial view so we can see it instantly. We can look back over the last 12 hours, 24 hours, 2 months, and also we can generate reports, which we do regularly for our meetings, to actually discuss how, where we could improve.
And when you take that kind of software, how much improvement have you made since you've had it? Have you been amazed that sometimes you look at a machine and go, gee whiz, that spindle's only turning for 35% of the time? We need to change that.
Well, it's something we've been involved in for a long time anyway, so I've always been of the opinion if you can't measure it, you can't improve it. So we've traditionally used timesheets in the past, and what we try and do, every job that comes onto the shop floor, we have a predetermined cycle time, setup time, tooling list, tooling cost, material cost, all that information gets gathered and goes back into the office. And then basically what happens is that the cycle times, all the various elements of what that make the job up in terms of cost are then compared to what we actually should have done. And if it's not achieved, it goes on to kind of a hit list then for the following month's meeting to discuss, is it an engineering issue, is it a quality issue, is it an issue with a breakdown issue on the machine, or have we just got to simply go to the customer and say, hey customer, we need more money, which we obviously don't like doing that, not with the customers.
And when you consider the maintenance one, how do the Nakamura machines have fare there? Are they pretty reliable?
Yeah, they're fantastic machines, to be honest. Obviously the newer machines, when you're pushing the boundaries in terms of technology, you can get some teething problems in the early days, but things like the NTY3, just a fantastic piece of machinery, never goes wrong, it just keeps...
Well, that's the thing with Nakamura. When we were at EMO, we were on their stand, and it just seems like everything is evolving so quickly. New models, new software. They're right at the front of kind of twin spindle, twin turning, multi-axis machining, aren't they?
Well, I think what's happened is that over the years, my opinion is that during the last recession, a lot of people, all happened very quickly. A lot of the maybe some of the old school guys were retired off, early retirement, that kind of thing. And what's happened as the economy has kind of grown again in the manufacturing sector, I just think you've got a lot of younger engineers come to actually understand the modern technology and actually using that technology within their designs. So whereas before we were using some of the latest technology to do very simple parts that could have been done, we were competing with people in other countries on cam autos and such like, we suddenly found we got all these complex parts that we had to make all of a sudden, which for us was awesome because we already got the kit to do it and the know-how. So actually what's happened really, I think the industry's kind of caught up really now with what the likes of Nakamura producing machinery actually the market's demanding in terms of producing more complex designs that we have to try and make machines that we can produce easily.
And is there a lot to be said about a Japanese-built machine like the Nakamura's?
Yeah, obviously it's an opinion. My personal opinion is that the Japanese machines probably are the best, and probably followed by the Germans.
And what about the engineering technology group? You can't just buy one of these machines without having a company that knows all about that technology and can support that. Have they scored quite highly on that front?
Yeah, absolutely. We've obviously putting a machine like this in, it's quite a big step because it's a very high-tech piece of kit. We have to be very confident that they can support the machine. And to be fair, we've had one or two issues, recurring issues in the early days, and now we're all over it. We've got some very good engineers that know what they're talking about, and it's not been a problem.
So I'll take from your comments then that when they say it's one of the best machines in the world, you're likely to agree.
Absolutely, yeah. And I tell you, we believe that Nakamura probably is the best, and that's my personal opinion.